Alright, what is nuclear fusion? The idea of nuclear fusion is popularized due to increasing demand for energy. In order for fusion to occur, the fuel needs to be in a state of plasma, which is a fourth state after gas. Plasma is when electron is completely ripped out of the atom. In order for plasma to happen, it has to be in an extremely high temperature, around 100 to 150 million Kelvin. Typical nuclear fusion reaction involves two different particles, such as deuterium and tritium. As you can see in the picture, deuterium and tritium fuse to produce two other particles, helium and neutron, and a massive amount of energy. To sustain such high temperature, the plasma must be kept away from the wall, as wall have a relatively lower temperature. The nuclear fusion reactor tokamak tried to resolve this issue by having a donut-shaped vessel with the solenoid at the center that induces current and a special coil that generates magnetic field around it, making the current flow, which makes the plasma flow through the donut-shaped vessel and sustaining and making it stay away from the wall, sustaining the temperature. And there may be some impurity in plasma which can seriously lower the temperature. Scientists have tried to resolve this in two different ways. They try to inject highly energetic fusion particles such as deuterium and tritium. They've also tried to use radio frequency heating, which involves highly powered radio waves that can be absorbed by plasma, which overall increases the temperature. However, there's one main drawback of tokamak, which is that as the current in plasma keeps revolving around the donut-shaped vessel, it will eventually increase, which heats up the reactor, and this just makes it impossible to sustain the reaction for a long period of time. And Stellarator tried to resolve this issue by changing the geometry of the reactor. As you can see right here, unlike tokamak, the magnetic coil is twisted a little bit in 180 degrees, forming a racetrack shape, and the plasma itself is also twisted as it flows inside the magnetic coil. And this geometry basically allows the uplifting drift on one side to cancel out the downlifting drift on the other side, which overall reduces the induced current and which allows the reactor to heat up less and sustain for a longer period of time.